everyone. My name is Muhammad Gibran Dzikry. I am doing my part of the group project for the two's complement hexadecimal for computer organization and architecture course. Here are my team members, and I will be responsible for the pseudocode. Before we're moving on to the pseudocode, we will take a look on what we will need to do on the project of two's complement with hexadecimal. So we were told to write an assembly program converting a 4-digit hexadecimal integer to its 2's complement. So the implementation is suggested here. The program will receive a 4-character hexadecimal digits, and it will loop through each character digit from right to left. And first, it will get the hexa character digit, and it will make it uppercase if it's necessary, and then convert the character digit into a number value, and it will reverse every bit in the hexadigit and then plus 1 to the lowest digit. This is the process of the 2's complement. And then after that, it will convert each number value back to the character digit to display. So the pseudocode, we actually divide the procedure into a few procedure here. We have the main procedure, the convert to upper procedure, the convert string to digit procedure, validate hex procedure, and last, the calculate to complement procedure. So the first procedure is the main procedure. It is the main procedure that controls the flow of the program. It starts by clearing the screen and then enters a loop where it prompts the user to enter a 4-digit hexadecimal number, and it will convert it into uppercase. After that, it will display the user input, and then it will convert the string here from the user input into digits and validates the hexadecimal input before calculating. If it's invalid, it will display error message. If it's valid, it will continue. If it's invalid, it will display error message and ask the user if they wanted to try to enter another 4-digit. After the two's complement calculation, it will display the result back in the character type, data type, and ask the user if they want to try again. If the user choice is Y, here it will go back to begin. If it's not, then the main procedure will end. Moving on to the second procedure here, we have the convert to upper. So this procedure converts all lowercase letters to uppercase. So for each character in the user input, if the character is lowercase, the ASCII value between 97 and 122, if you look at the ASCII table, the integer value for 97 is actually the character for lowercase alphabet of A, and until 122 is the lowercase alphabet of Z. Now, if you look here, it will subtract 32 from the ASCII value of the character to convert it to uppercase. So if we subtract 32 from 97, it will return 65, the uppercase of the character here. That is the procedure of the convert to upper. Now we're moving on to the convert string to digit procedure. For each character in a user input, if the character is a digit, ASCII value between 48 and 57, here is 48 to 57 is actually 0 to 9. It will subtract 48 from the character to convert it into its integer value from the ASCII character. Okay, here. The ASCII character is 0, 9. It will subtract the 48. So 48 subtract by 48, we're going to give 0, and it will have the hexadecimal equivalent of 0 to 9. And now if we have the character in an uppercase letter, because we already converted to upper, the value would be 65 to 70, because we only using until F. 10, 11, 12, 13, 14, 15. So it will subtract 55 from the character to convert it to its integer value. So it will minus 55 will result in 10 until 15 for the hexadecimal here. And after that, after each of the character are been converted, it will end the procedure. Now, after all the character from the ASCII that have been converted to its integer value, it will go to the validate the procedure. For each character in the user input, see here, if the character is greater than 15, display the invalid input because you can only use the hexadecimal character from 0 to 15 here. And if it's greater than 15, it will display invalid input. And the user, and ask the user if they want to try again. If not, then end the procedure. And lastly, after everything is been validated, it will calculate the two's complement. So it will initialize a variable to 0 for each character in the user input that has been validated. It shifts the variable left by 4 bits and then adds the integer value of the character. It then performs the two's complement on the variable. So how it works is that by shifting the variable left by 4 bits and adding integer to the value character, it will turn the hexadecimal to binary, so it can perform two's complement on the variable. After that, it will display it back, turn it back to the hexadecimal here. And after that, you end the procedure. It goes back here, the result, and ask the user if they want to try to input another 4-digit hexadecimal integer. Okay, thank you. That's all from the pseudocode.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Aflakh Ibadurrahman from computing computer organization and architecture section 1, and this is my part for the project example for input and output. So there is a 4 example that would be present now. So for the first example, input and output for the code, please enter 4-digit hexadecimal.
Assalamualaikum, my name is Atharalikh Baihaqi Mubarak, and I will explain the demonstration of the code. So first of all, it will display the prompt 1, which is please enter 4-digit hexadecimal integer, for example A1, B2, and then it will ask the user input. So in here we are going to input our integer. After that, it will offset the user input to convert it to upper if it's necessary. If the user input it with a lowercase, it will convert it to uppercase, and if the user already input it with a uppercase, it will skip the convert. And then after that, it will display the prompt to memory, which is 2's complement of hex. After that, it will also display the user input and then display the prompt T. So it's going to be like 2's complement of hex, the user input, is the result of the user input. And here the user input will be converted from string to digit in here. So it's going to be if the user input with the letter like A, B, C until F. Just like hexadecimal, it will convert it to digit by using a SCII, just like my friend already explained it in the pseudocode. And then it will convert it to integer and it will convert it to char. Then it will also display the user input and then call validate hex to make sure to verify that the hexadecimal is not more than 15, it's not greater than 15. If the hexadecimal is greater than 15, it will display the invalid input and ask the user to ask if they want to try it again or no. But if the hexadecimal is less than 15 or equal to 15, it will skip the validation and then jump again to validate hex. So in here, the user input will be displayed and then also it will clear the line. This is clear line and then call get user choice. This means the get user choice is to ask the user if they want to try it again or no. So overall, it will look like this. As you can see, the first one is display is please enter 4-digit hexadecimal integer. We are going to insert A1, B2, just like in the two, and then we press enter. Choose complement of hex A1, B2 is 5E4E, sorry. And then the system will ask again if we want to try again, and we press Y. Please enter 4-digit hexadecimal. Now we are going to insert it with a lowercase. Just for example, A1, B2. You see, this is where the upper class convert to upper is executed from our input, which is the lowercase. It will convert it to uppercase, and then if we try it again with letter Y, for we are going to enter a full of number just like that. I mean, if we enter an input that is greater than 15, for example, like G or Y, U, T, it will still convert it into uppercase, but the result is invalid input. And that's all for me. Thank you.
Hello, my name is Muhammad Mujahidul Adli from Computer Organization and Architecture class, section 1. Okay, let's talk about conclusion. The journey in developing an assembly program to convert a 4-digit hexadecimal integer into a complement tool from symbolist teamwork and determination. From careful planning to coding in assembly language, we passed through challenges ensuring robust input handling and complements to understanding. Our programs, which are a testament to our understanding of the concept, have undergone rigorous testing and refinement, ensuring reliability across a wide range of scenarios. Going forward, we aim to improve functionality and optimize performance, strengthening practicality in real-world application. This project marks an important milestone in our understanding of computer architecture, demonstrating our ability to bridge theory with practical programming. This laid the foundation for innovation and continued growth in this dynamic field.